About section 1.5, combining functions. So when we talk about combining functions, we're talking about adding or subtracting as one possibility. Key thing to pay attention to here is the nomenclature, or what it's going to look like. So we're taking f of x plus g of x. An alternate way to write that is f plus g, then x. Both of these mean the same thing. Wait, subtracting f of x minus g of x, or f minus g of x. Either way is the same thing. Now, adding or subtracting is pretty straightforward. So if you had a function, such that, let's say, f of x was equal to x plus 3, and g of x was equal to x squared minus 7, f plus g of x would involve just adding them. Like terms, right? So in this case, x plus 3 plus x squared minus 7, and if we rearrange and combine like terms, x squared plus x, 3 minus 7 net minus 4. So fully simplified, that's what it would look like. Subtraction, you do need to pay attention to the following. When you're subtracting a function, you're subtracting all of that function. Probably your best bet. F of x would be x plus 3. Order does count. Minus, see what I did there? Grouping this. Which means that x plus 3, nothing really changed, minus x squared plus 7, because you have to distribute the negative. So in the end, the fully simplified form would be negative x squared plus x, not plus, minus g of x. So just don't forget that piece when you're subtracting. Multiplying or dividing. Multiplying, f of x times g of x, or f times g of x, or f divided by, or they might write it as a fraction, or f divided by g. So same kind of idea of the different ways you could write it. So let's take our same two functions. F of x equals x plus 3, and g of x equals x squared minus 7. So f times g of x would be all of x plus 3 times all of x squared minus 7. Do not forget to distribute properly. That is FOIL. So x times x squared would be x cubed. X times negative 7. I'm actually going to do 3 times x squared because I know that that's going to get me closer to standard form more quickly. And I have x times minus 7. And then 3 times negative 7 is minus 21. Which means that this right here would be the fully simplified form. I just happen to distribute it in such a way to get the simplified form quickly. So f divided by g of x, and we rewrite that. Looks like an actual division sign, but it doesn't look like it right now. F divided by g of x would be f of x over g of x. Now, they're probably going to ask you for any restrictions to the domain. So basically what you're looking for when you're doing this is g of x cannot be equal to 0, and also there can't be any fundamental issues, that is division by 0, that sort of thing, or any problems with respect to any of the other functions. And x plus 3, not a problem. Intrinsically, x squared minus 7, not a problem. But if you're dividing by x squared minus 7, that means that x squared minus 7 can't be equal to 0. So can it ever be equal to 0? Yes. X squared equals 7, so x equals plus or minus b squared root of 7. So you could say such that x is not equal to plus or minus b squared root of 7. An alternative way of writing that domain would be negative infinity. Negative infinity all the way up to negative root 7 union negative root 7 to root 7. Notice how I'm not including those values because I can't. That's the parentheses looking things. And then root 7 to infinity. My personal preference is x is not equal to plus or minus root 7. Some books may require this though, or you may see this on answers. And that is combining functions by multiplying, dividing, adding, or subtracting.